Hi guys, today we are talking about sketching functions from verbal descriptions and how does that sketch of a graph of a function help it describe its behavior. So the first one is going to be a linear function. A scuba diver starts a dive with a full tank of oxygen. While diving, she breathes at a constant rate. She checks the gauge after 22 minutes. What does a graph of this function look like? So it says at 0 minutes, the oxygen is full. So one of our variables is going to be time. And then we're looking at the level of the oxygen. So I'm going to label this oxygen level. So at 0 minutes, it's full. Okay, so that would be half, approximately, and that would be empty. So she's starting here, 0 minutes, full tank of oxygen. 22 minutes, she's half. So 22 minutes, she's at half. Then if it's a constant rate, it should be a straight line. So I'm just going to continue this. If at 22 minutes it was at half, then at 44 minutes it would be empty. So that's what the graph of that function would look like. The next one says Danica sketched the relationship between altitude and time for one of her ski runs. Describe the behavior of the function in each interval based on her sketch. So this was her sketch. Okay, so we need to describe this. So in section 1, and this is time and altitude. So that's the sketch they gave us. So we're just going to describe this based off of her ski run. So if her altitude is increasing, so when would her altitude increase? When she's going up to the top of the hill. So I'm going to say she is on the ski lift going to the top. 2 is constant, so she's not changing altitude. So 2, she is at the top, but she does wait a while here, so I'm going to say and has to wait for her turn and the ski run to be clear, or something like that. I don't know exactly how skiing works, but so she's waiting for her turn to go on her ski run. And then section 3 is going down, but if you notice the altitude goes back to where she started, but she does this a lot faster, the amount of time this takes versus the amount of time this takes, and that's because she's going faster down the mountain than it took her to get up on the ski lift. So section 3, she is skiing down the mountain. Okay. All right, just a few more here. This one says, Jose is practicing javelin throws. What is the relationship between the height of the javelin and time? So over time, what is the height? And what would the graph of the function look like? So if you think about, if you throw something, it's not going to stop midair. So this should be continuous. Okay, so I shouldn't have any flat parts because the height's not going to stay the same at any point. So really, it's gonna go up, but the javelin doesn't start from the ground because they're throwing it. So it starts with wherever their height is, wherever their arm is. So I'm gonna say the javelin starts there, gets thrown up, and then comes back down. It is gonna land on the ground though. So this would be the maximum height that the javelin reaches. This is, again, the height of the person's arm when they're throwing it. And then this is the javelin falling to the ground. All right, I want you to go ahead and pause this real quick and try this one. It's on 197 if you want to actually draw it on paper, or you can just screenshot this and then come back and watch the rest. So Haru rides his bike from his home for 30 minutes at a fast pace. He stops to rest for 20 minutes, and he continues in the same direction at a slower pace for 30 more minutes. So this is distance away. Sketch a graph of the relationship of Haru's distance from home over time. So he's not going to end back at home because he goes away from home, he stops, then he goes further away from home. So my graph should not have him coming back home. So my graph's not going to come back to 0. So he rides for 30 minutes, and he gets pretty far since he was going at a fast pace. He stops for 20 minutes, so if this was 30 minutes, it should be a little bit less than that. There's 20 minutes. And then he goes for 30 more minutes, so about here. But this one's at a slower pace, so he's not going to get as far. Okay, so that's what my graph looked like. If you have this general shape, then you're good. If the shape's not the same, then reread this and rethink it through. You're going to be drawing graphs and writing descriptions today. Let me know if you have any questions.